for having me. So I'm an associate structural engineer for TTW and a team lead for their construction engineering department here in Melbourne. We work pretty closely with contractors and subcontractors generally to help with providing temporary structural solutions and sequencing to ensure the safety or stability of a structure during various phases of construction.
Yeah, awesome. And it's such a unique team and skill set, and really important that you bring to projects I don't really think any other teams out there are really doing. So there's a whole host of challenges that we can get into that you're dealing with. I mean, one of them could be around mixing materials on site. So what are some of the issues when you've got multiple materials for, say, the one floor plate?
Yeah, so what we would generally find with the mixed construction, one of the bigger sort of points to raise is the coordination between subcontractors. And that'd generally be between steel and timber contractors, because often they're sort of intermingled. The concrete is generally pretty straightforward and it goes up without concern. But depending on the details, you might have any number of those respective contractors working in the same space. And so I think when we're going through that design process, it would be worth pausing and considering whether or not one material is useful or practical to be used in that space, because that'll basically hopefully have the benefit of reducing the various workers in that same area, maybe even de-risk that space. And it could also possibly reduce the delays. So an example might be if there's a delay, if your system's relying on the steelwork for support, vertical support or lateral support, and it gets delayed, then the timber gets delayed. So there's the possibility there to sort of help combat that. The second part is probably in the same vein. It's the dependency of the stability of one material relying on another. And so we've had a couple of examples recently where you'll have steel elements being erected in isolation to the timber, but then the steelwork relies on the timber in the permanent case for that lateral load path or lateral stability. And so in that instance, there's, I guess, more sequencing involved, or even more temporary works involved. So again, coming back to that design role, it's worth considering whether or not we can separate the lateral load paths of one material from another, because that'll allow the contractors to move into a space, leave their work stable, and then get out of the space. And then, the other material subcontractor can then go about their way. So that's probably the two main points that come to mind with those mixed construction sites.
I'd imagine it's also a challenge for, working in modelling. And I remember a project where, for shop drawings, it's just hard to know what's actually going on with steel, and then coordinating shop drawings between the design team and who's got the 3D model, and taking it from the steel work to the CLT, but all those complexities. It doesn't seem like glue lams. If you work with, say, glue lam and CLT, which I guess are two different products but same material, just doesn't seem to have the same sort of level of issues that you're talking about here. Yeah,
that's right. I think with the mixed material, there's just an extra level of coordination that, with a bit of engineering smarts at the start, could possibly be mitigated.
Absolutely. So, it's probably underappreciated for sure, that designing for the stability and the temporary cases. What other elements, or is designing for installation often underappreciated in your opinion?
I think to a certain degree, and the main items that come to mind are the manoeuvring or handling of, say, timber trusses or segments of timber trusses, and even mass timber elements to that extent. And I think just their handling in both the warehouse context as well as on site. So it's in my opinion, it's fairly important to understand how something is intended to be handled, whether that's in a controlled environment like the warehouse or out on site, to even understand how it's delivered. Is it going to be sitting on some sort of stillage? Is it laying on its flat? Those sorts of things. And I think in knowing that at the early stage, we can then put strategies in place or design secondary steelwork elements or whatever we need to do to help to help with that process. I think a key part of that is the fact that, if we think about the two materials, steel and timber, in the context of a truss, a steel is much more forgiving if it's handled incorrectly than what a timber truss may be. On top of that, it's also the protection of connections or splices when we are doing that handling or lifting, again in the warehouse or on-site context, because often what we'll find is that's possibly one of the more critical instances for those connections. Take a splice, for example, in a strong axis, it's designed to bend, but then if we're lifting a truss from a truck bed, it's bending in its minor axes or weak axes. So it could be more adverse for those connections. So it's important to know, as I said, how it's being delivered, so then we can put certain strategies in place to protect it.
Yeah, 100%. I was just going to say, I'd imagine it'd be so easy for a builder to get a truss delivered on site. And if they haven't been told before that you just pick it up on the weak axes and lift it that way, have you seen anything like that before?
I think you'd be interested. It's interesting. I think it's important for our contractors and subcontractors to understand that they are very sensitive to how they're being lifted. And so I think what you would find is, particularly from a delivery standpoint, someone might be familiar with a certain process that they've adopted for steel roof trusses, and it's not directly transferable to the context of timber. There have been instances, and they were pretty swiftly corrected. The last point, just in terms of design for installation, as you know, most of the mass timber structures are going to be post and beam construction, column and beam. And so they sort of lend themselves quite neatly to the stick-built methodology. But during the construction phase, there might be some critical connections there that are quite sensitive to unresolved load paths. So, generally it's a pin connection, but you could have instances with cantilevers, etc. So just from our design perspective, and it could be high level and indicative, we should be picking up on those sorts of things just to have a bit of a forward think about, hey, is the load path unresolved here? Does the contractor actually need to think about having a vertical prop or any lateral props in place? Because that sort of at least gives them, it gives them a bit of a hand when it comes to building the structure as to what is actually going to be critical for a connection in the temporary state.
What sort of, for temporary works, what sort of things need to be allowed for in the design?
Yeah, good question. So again, coming back to just the traditional post and beam construction, it's pretty common practice to have all your columns propped in two directions orthogonally. That's pretty much the basic one. Depending on the level of involvement of the designer or, in the engagement of the temporary works engineer or construction engineering, you also think about some high level input into the installation methodology. That could be as simple as bullet points. It could also indicate, as I was talking about before, lifting points on a truss. I think, again, with the timber trusses, that's pretty important. So as a designer, I'd want to know how they're lifting the truss and that it's not going to be affected. And then for the strategies, it could also go through to being as complex as a 3D animation. Again, that'll just be that's generally dictated by the complexity of the project. For our mixed construction, so when we've got timber or in situ concrete or precast, it's always worthwhile considering any back propping loads or inclined propping loads from our precast elements onto CLT or our glulam beams. And then some of the more general ones are storage areas on your CLT. So that could be, Rio mesh, insulation, plasterboard, etc., through to equipment loading, so scissors, booms, etc. But one of the bigger ones that's come out of lessons learned is just those sort of, I guess, in the context of timber, heavier bits of equipment. So your Alimax or your tower cranes, anything that's relying on the permanent lateral stability system. It's fairly important to have those early discussions with someone that's familiar with developing the, say, tie loads into the diaphragm If you think about an allimac or a tower crane, generally sort of bolting into the side of a concrete diaphragm. But when it's adopted in the context of CLT, it's not necessarily directly transferable. And what we often find is that the connections become quite onerous to deal with those same tie forces. So you might need extra drag plates or secondary steelwork to help develop the same loads through the CLT diaphragm over and above what you would need for a concrete slab. And the more recent example that we have is La Trobe University student accommodation. So I think in that instance, it's pretty important when you are thinking about connecting an allimac, or hopefully not a tower crane, but at least allimacs, we're talking early with your design teams to help manage panelization to optimize any of those connections as best we can up front.
Yeah, so a lot of the time you're saying that you screw design, I guess, or your panel to panel connections for the permanent case might not be enough to get it over the line for something like an allimac compared to a concrete building, right? It's just be an afterthought and you wouldn't even have to worry about it.
Yeah, exactly. You're generally trying to deal with, for lack of a better term, block shear failure through the CLT panels, or unzipping of those traditional splice or spline connections between CLT panels. So it's all about, I guess, if you think about it, engaging as much of that as you can to dissipate the same force.
Yeah, makes sense. One of the biggest reasons that builders and developers want to go with mass timber and CLT is because they're trying to get the speed of construction as one of the things to optimize for to save on costs. So from your experience, how can builders go out there and improve their overall speed in construction from smart design?
Yeah, I think it's an easier one to get across the line is considering some level of fixity at the base of columns. If we can stand columns up and have some level of base fixity, there's the potential to reduce the amount of temporary propping. So I think base fixity is pretty important. So if we can sort of lead further away from pinned connections at the base, the moment fixity will definitely help there. Just in terms of hire and procurement of props, but just the quantity of fixings. So there's cost saving there as well as the time saving. The other one that comes to mind is considering whether or not within the design remit, we can start nominating the amount of fixings that are required to let go of a beam or a bracing element from the crane, that is. Because often what we'll find is that may not necessarily be 100% of the fixings. So the less time that the crew's up there fixing off all the connections in that fixing, they may only go from, it may only be 80% of the connections, but that's a time saving for them that they can then move on to the next beam and the crane can be released to go about its way with the remainder of the build. The other sort of more general ones, which are sort of done across the industry at the moment, are pre-installation of connections or bracketry, if and where you can. You can even consider pre-installing some of the inclined props when you're lifting in mass timber elements. And then I guess a more difficult one, but where you can, you should accommodate for it, is modular construction. So if you can sort of modularize any of the components and lift them into one piece, that's obviously going to speed up some of your installation.
And that's super exciting, particularly around modular construction, if things head that way. You've had some great experience at TTW. You've been on some of the leading projects in Australia. So what have been some of the major lessons you've learned on the projects you've been on?
Well, one that I hadn't thought of before, which was an interesting one to come across, is just the supply of screwed fixings, particularly with a lot of the fixings coming over from Europe. So I think in the front end, when we're going through the temporary works design, it's worth having those discussions with the delivery team as to what their suppliers have at hand at stock, because often that will then help with making sure the connection, they can actually get their hands on those screws. It'll also help reduce RFIs and the throughput of design changes if needed, if they can't get the supply of certain screws. I think just generally having a bit more of a careful consideration for finished surfaces, because often what we'll find is that any of our temporary components are fixed onto a finished surface. So it's just having that forward thinking of how can I actually save damaging the timber. And there's often a trade-off between trying to resolve forces and limiting the damage to the timber. So it's an interesting balance.
So on that one, Lincoln, what I mean, if you do damage a bit of the timber, there's different ways that can happen. I mean, the slings, just not having any protection with the timber or moisture or all sorts of things. So what sort of remediation and fixing can be done, and is it a huge issue?
It will, where you can, I think, where you can, if it doesn't obstruct your installation, we should think about trying to fix in the areas where it's going to be hidden. So if you have the notched end of the column where it's going to accept future beams, that's one area that you can consider the fix within. If the permanent detail has a bolted connection at the top, thinking about trying to coordinate the temporary connections with the existing bolt holes, those sorts of things will help manage damaging the finished surface of the product. But obviously there are other instances where it's either obstructive to your installation. So I think you've got to temper that with, it may not be the best strategy. It might be better time spent in actually face fixing than to, as I said, have temporary works which possibly is obstructive. So it will change from project to project and from sequence to sequence.
Yeah, that makes sense. Was there any other major lessons learned on your project?
I had two more that sort of crossed my mind. I think in the lifting space, there's quite a bit of work to continue to be done, particularly for face and edge fixed lifting products or assemblies. The last point was just the use and development of 3D models is absolutely priceless. I think in two facets, it's a great marketing tool that makes things look, thought through and detailed, but it also helps alleviate RFIs because when we have a visual representation of a written methodology or a 2D methodology, things become so much clearer in 3D. So I've just personally found that, working in that 3D space is absolutely essential. And as I said, it makes the process a lot smoother for all involved, particularly when we're either working remotely from our delivery teams, or if we're just working remotely even from our own organizational perspective. So as I said, 3D models pretty much priceless.
Well, there's been so much we've taken out of this, out of all your knowledge and all your golden nuggets you've taken along the way on your journey, Lincoln. If people want to find out more about yourself and what you do, where do you want to send people?
They can just jump onto the TTW website. There's links to my bio as well as our company-wide portfolio of projects. You'll see a lot of mass timber structures there. So hit us up on the website.
Thank you so much, mate.
Not a problem. Thanks for having me.